Hello, my name is Robert Smith and I'm with New River Community College's Academic Assistance, and today we are discussing titrations. We have just a couple of problems, and at the end of working through these problems, you may have a better understanding of how to work through a titration problem. So let's begin. The first problem says if 32.84 milliliters of potassium hydroxide solution is needed to neutralize 0.4586 grams of hydrochloric acid, what is the molarity of potassium hydroxide? And in order to do this problem, first we're going to have to recognize that we are going to use the molarity formula, which requires that volume be in the form of liters. So the first thing we're going to want to do is convert the 32.84 milliliters over to liters. 32.84 milliliters times 1 liter over 1,000 milliliters is equal to 0.03284 liters. Then we need to recognize that we need to find out how to change the grams of hydrochloric acid into a unit that we can use in our molarity problem, because that is what we're trying to find. The easiest way of doing that is to convert grams to moles. So we'll start by saying that in order to do that, you're going to have to find the molar mass, or molecular mass rather, of hydrochloric acid. And if you recall, all it is 35.45 grams per mole plus 1.008 grams per mole, or 36.46 grams per mole. So we can find that moles are equal to 0.4586 times 1 mole over 36.46 grams. And when you do the arithmetic out, you will find that you end up with 1.258 times 10 to the minus 2 moles. From there, we can calculate molarity. Molarity is equal to moles over volume. Volume has to be in liters. So in this case, we have 1.258 times 10 to the minus 2 moles divided by 0.03284 liters. Easier to write that would be 3.284 times 10 to the minus 2 liters. That way, you're simply dividing using scientific notation. And when you do the arithmetic out, you find that your molarity is 0.3831 molar, or you could say just as easily moles per liter. And that's all there is to that. And the reason why that was all there was to it is because for every 1 hydroxide produced by the potassium hydroxide, hydrochloric acid produced 1 hydrogen. So in order to neutralize it, it was a 1-to-1. Things are not quite that easy on our next problem. How many milliliters of 0.160 molar KOH solution is needed to neutralize 30.0 milliliters of 0.425 molar H3PO4 solution. Again, we're going to want to convert milliliters to liters because we're going to be dealing with a molarity problem, which means that our 30 milliliters up here is actually going to be 0.0300 liters, if you'll permit me the brevity. So going back to what I said earlier, this one is not as clear cut, and the reason for that is that we have to take into account the equivalency. Recall that molarity times volume times equivalency of the acid or the first item, whether it be an acid or a base, is equal to the molarity times the volume times the equivalency of the second species during neutralization. And in this case, we're looking at one of them having an equivalency of 1, which is the OH. Potassium hydroxide only produces one hydroxide ion in solution, versus over here, our acid is producing 3 hydrogen ions in solution. So we've got a 3-to-1 ratio. So we're going to start by looking at what we can determine from what is listed here. Well, note that there is this 0.425 molar. When I'm looking at trying to break things up, I want to find the easiest way of doing it. And given that we have the liters and the molarity of our acid, let's just go ahead and find the moles. So our moles of H3PO4 is equal to 0.425 moles per 1 liter. It's the same as saying 0.425 molar. And then multiply that by the 0.0300 liters. Our liters and liters cancel each other out, and we're left with our moles, which are 0.0128 moles. To find our moles of KOH, we're going to have to take the moles produced by our acid and multiply it by 3, which is the equivalency. For every 1 mole of acid is producing 3 times the amount of hydrogen ions than 1 mole of KOH. So we're going to take 3 times the 0.0128 moles. And the reason for this is because you're going to need 3 times the amount of KOH to neutralize your H3PO4. So when you do the arithmetic out, you end up with 0.0384 moles. Then it's simply a matter of looking at our original problem, and it tells us the molarity of KOH, and now we have the moles of KOH. So we can then determine the volume. Volume is equal to the moles divided by the molarity, simply manipulating the molarity formula, which in turn means that 0.0384 moles divided by 0.160 moles per liter, which is the same as saying 0.160 molar equals 0.240 liters. And if we wanted to, we can look back and say, are we done? In fact, we are not, because of this little fact right here. They want it in milliliters. So before you ever submit any problems, this is a great example. You'll want to reread the question to make sure you're not missing something. Because if you submitted a work with this, if it was multiple choice, which most of the exams are for chemistry, then you would find that you would get a big fat 0 for this, even though you did all that work. What you want is to reread it and make sure that you're using the proper units to express your answer. So we can then take our 0.240 liters, multiply it by 1,000 milliliters over 1 liter, and have it so that liters and liters cancel each other out. So we're left with 240 milliliters. And that's our final answer.